With heating season fast approaching, I thought it would be a good idea to review the sequence of operation of a gas furnace. If you've taken the NATE certification test, there is a question on the NATE test regarding the sequence of operation of a furnace. So let's review the sequence of operation. First, there's a call for heat from the thermostat. Then the inducer motor starts, and the pressure switches close. The igniter glows, the gas valve opens up, and the flame is established by the flame sensor. And once the timer times out, the circulating blower comes on. It's very important for a technician to know the sequence of operation of a system so that you know what it should be doing versus what it is doing. So the first thing that's going to happen is the thermostat is going to call for heat. And you need to be able to check out the thermostat if this doesn't work. The best way to do that is take a voltmeter, and we're going to check between R and W to see if the thermostat is calling for heat. If you remember your NATE certification test or your basic electrical class, you will remember that when a switch is open, you will have 24 volts. When a switch closes, you will not have voltage across that switch. Same thing with the R and W on a thermostat. With the thermostat not calling for heat, the switch is open, and so you will read 24 volts. When the switch closes and the thermostat calls for heat, your 24 volts will go away and you will not read 24 volts across R and W. Another way you can check the stat is by checking between common and W, and this works exactly the opposite. If the thermostat is calling for heat, you will have 24 volts between common and W, and if the thermostat is not calling for heat, you will not have 24 volts across common and W. The R to W method is most commonly used as some thermostats do not have a common terminal. The next thing that happens is the inducer motor starts. On most modern gas furnaces, you either have a PSC inducer motor or an ECM inducer motor. You need to be able to troubleshoot both. On a standard PSC inducer motor, you're going to have a number of leads that go to the motor. In this case, you have a low tap and a high tap and a common. So between the common and the low tap for heating, you should have your voltage to run the motor. An ECM inducer motor will have high voltage supplied to it at all times. Then you will have control wires that go to the motor that will give it the signal to run. In this example, we have a pulse width line, which has DC voltage supplied to it for low and high speed. We also have a RPM feedback line, which feeds back to the control board and tells it that the inducer motor is running. So when you're checking ECM motors, you need to have these voltages so you know how to troubleshoot the ECM motor. The next thing that will happen will be the pressure switch closes. Furnaces can have up to 3 pressure switches: a high pressure switch, a medium pressure switch, and a low pressure switch. The make and break points for these switches can be obtained from the manufacturer, and it is necessary to properly troubleshoot the pressure switch. You will also need a manometer and a T to tap into the pressure switch hosing. You will also need to be able to troubleshoot the pressure switch electrically by checking with an electric meter to see if there is continuity through the switch or not. Checking to see if the switch closes when it's supposed to. Also, don't overlook the fact that you should check the wiring of the pressure switch circuit where it enters the board to eliminate any break in the wires that go out through the furnace to the pressure switches. Next, the igniter will glow. The hot surface igniter will work within a voltage range of 102 to 132 volts AC. When the HSI is in good shape, it will read between 40 and 70 ohms at 70 degrees. The next thing that will happen is the gas valve will open. There is a 24-volt signal usually to open the gas valve. Make sure you check the supply gas and the manifold pressure to make sure there is sufficient pressure there for the gas valve to operate. Many modern furnaces now have a modulating gas valve and usually has a 5-pin connector to the gas valve. Through this 5-pin connector, the gas valve receives various signals to make sure that it operates correctly. You can get the values for each pin from the manufacturer of the gas furnace. After the gas valve has opened, there should be ignition on the burners. The flame is then established via the flame sensor. When in the flame, the sensor should read between 4 to 6 microamps. This can be read by putting your multimeter in series with the flame sensor. Also, make sure you have a good ground on the furnace, as a good ground is necessary for the proper operation of the flame sensor. After the flame has been confirmed, and after a period of time, the blower motor will start up. Again, as with the inducer motor, you have a standard PSC motor and also ECM motors for the blowers. On the PSC motor, you will have various connections for the various speeds of the motor. In this example, we have a common that is tied back to the line voltage, and then we have our cool tap that is connected to the high speed of the motor. Our medium high is not connected. Medium low is connected to the heat connection, and our continuous fan is connected to the low speed. The ECM blower motor, just like the inducer motor, has high voltage supplied to the electronics in the back end of the motor continuously. Then you need to have the schematic or the troubleshooting guide to know what lines we have DC voltage to send the signal to the motor. In this case, we have 12 volts DC that's supplied on the red and green, 5 volts DC supplied on the yellow and green, and 0 voltage, which fluctuates several times per second, on the yellow and blue. Once again, this information can be obtained from the manufacturer of the equipment. So as we head into the heating season, it's very important that you as a technician understand the sequence of operation of a gas furnace so that you know how it's supposed to operate so you can properly troubleshoot the system. We also in this video have given you various information concerning gas valves, pressure switches, and motors. This type of information you as a technician should have in your own library on your phone or a tablet or a computer. Most of this type of literature can be downloaded from a manufacturer website and placed on your tablet or your computer for your future access. When you go to work on a furnace, you need to have this information available to you so that you can properly troubleshoot the equipment and get the job done quickly and efficiently.
Go to Airefco.com for more videos, like, subscribe, and check back every week for new videos.